Good morning, everyone. And here is a video on how to do change of bases. Okay, I always try to say something about change of bases. Is that there are many resources online, which is really helpful. So I'm just being a contributor to one of them. Okay, and it's not that my system is the best one or anything. You should try to see how others great mathematicians do things. My method is probably not 100% conceptually correct, in the same sense that I'm going to use some notation which is a bit suspicious. Okay, but the whole point of this thing is to make you realize what exactly is doing, a change of basis, what is a B matrix or something like this. And after you understand the notations, you can try to pursue for the precision of your notation or etc. Okay, so points. So you should consult other video for precision. So if you are really looking for precision and you already understand, then you probably don't need to watch this video. Okay, and the thing is not notations not standard. Or even abysses. Okay, but as I say, the main point of this video is to make you realize how to do things instead of to give you the formal definition of everything, because formal definition probably you can't work with it very easily the first time at least. Okay, so first of all, let's start by coordinates. Okay, so the main question is really that what is the coordinate of this thing? So you will say, oh, it's easy, right? We all learned this in high school, right? It's 3, 2, because this is the horizontal 3 and this horizontal 2. It's vertical 2. So it's 3, 2. But if you think carefully, what exactly this 3, 2 means? Actually means that you are actually implying that you have a factor E1 and E2, which you know that is called the standard basis, right? E1, E2 standard basis. Okay, and this factor is actually you just add up these things, right? You're adding up it's the same as you have 3 of E1 plus 2 of E2. Okay, and that's why we mean that by 3, 2. So in fact, this 3, 2 is not that we just randomly read from the coordinates and read from the x's and now we just fill it in. It's not like this. But the 3 here is a coefficient corresponding to the first factor, and the 2 here is actually the coefficient which is corresponding to this factor. Okay. Okay. So in fact, for say for example, let's be say 1, 2, 3, 5. Okay, it's a basis. Okay, you can check. You should check linear independence or spanning any sort of things. But now if I assume that is a basis, so for example, for this factor, we can write it in terms of this, right? Like this. So we'll just say the coordinates with respect to B, okay, of 5, 9 is actually the 2 and 1, right? You remember we are taking the coefficient. By the way, if you don't have coefficient, it's 1. Okay, so actually this 2, 1. this 2, and this 1. So it's called the coordinate system, okay? The coordinate system over the basis B. Okay, so now like the first thing is like solved, so we know what is a coordinate. But I mean, finding coordinates are difficult. You're saying, nah, I mean like you're just like just writing down like 2 and 1. How come it would be difficult? Okay, so imagine. Now I'm not giving you this. I'm just asking what is 5, 9. It's difficult, right? I mean, now how come you know that it's like even 2, 1? How come you know? It's just like you just don't know, right? I mean, like you have no like it's just not going to work, right? The point that like you know that this 2 and 1 exists is just that you solve the equation. So for every single coordinate, you need to solve an equation, which is extremely tedious. Okay, so it is difficult. Okay, it's difficult. So let's talk about another thing. Okay, so let's talk about transformation matrix, okay? So what is happening here? In fact, you know, like if I'm giving you 2, 1, if I'm giving you 2, 1, it seems to be very easy to get this 5, 9, right? If you give you this 2, 1, how to get the 5, 9? You're just multiplying. So this direction is very easy. Okay, so that's fine. So let's try to imagine an operator. Like I will fill this in, right? Okay. So it's an operator which input is like 2, 1 and the output is 5, 9. Okay. So what would it be? Or how should we think it? Like, or what is the the concept between them? Okay. So the concept is as follows. Is that it's a transformation matrix. So say like M from what is this coordinate? You remember this 2, 1 is a coordinate in the B system, right? So we say it's a B system. So this is the input. Okay, so let me write down. This is the input basis. And what is outputs? The output is a standard basis, right? Standard basis, I just use STD for standard. So it's the output basis. And now you are saying like the input is like a B and the output is like a standard, okay? And here is how we define this operator. Okay? So this operator is like having like the input is like a coordinates in the B system, in the B basis, and the output is in the standard basis. That's all. Easy, right? Easy. Fact. M STD B is actually linear, or like it can be represented by a matrix. If you really follow me through, then you can see that quite easy. Why? Because this thing is actually this, right? You remember like how to give like 5, 9 is by like inputting this 2, 1 into this thing, right? So in fact, like here, how it will be is like if you have AB, then you're just having A of 1, 2 plus B of 3, 5, and hence it's linear. You know how linear math looks like, okay? But we want to find the matrix, okay? So then what is the matrix? Okay? The matrix, like, let me write down, the BSTD. What it is, right? This is the ultimate question. Ultimate question. Okay, so to find a matrix, the easiest way is to use the standard coordinates, standard basis. What I mean is as follows. So let's try to like analyze. This thing has an input of 2-dimensional and the output is 2-dimensional, right? Input, output are 2-dimensional. So this thing should look like something like this. So like you have like a 1, 2, 3, 4. It's a 2 times 2 matrix. Okay. So it's like something you should like have in your mind. I will probably make it in gray because like, it's not like the main points here. Okay. But if you're trying to do like, for example, 1, 0, what does it really give you? If it is a matrix and you multiply by 1, 0, what it will give you? 1 multiplied to here is the output of the first thing. 1 multiplied by this will give you the second thing. So in fact, the output is actually this thing. Okay, these two are the same. But what I mean, like here we actually know what is the output. Okay, so this thing, like let me try to pronounce you again. Okay, so remember, like it's always like you want to pronounce the like mathematical notations because they are so heavy. You want to pronounce them to make yourself like more awake. Okay, so how to pronounce it? So let me pronounce it to you. It's like transforming a coordinates in B to coordinates in standard. Okay, so this is a coordinates in B, and then you want to find the coordinates in standard. Okay, so let me copy it down. Let me copy like the bases down so that you can like look at it. So this is the basis. And now, so the coordinate in B is 1, 0. What does it mean? It means that it has 1 copy of this and 0 copy of this, right? And hence, the output is just 1, 2. Because in standard coordinates is 1, 2. Easy, right? Easy. So this 1, 2 will actually give you this 1, 2. Because if you let me like try to remind you again, this thing, the output is given by like the multiplication from here, right? But this is 0, so this useless, and that's what this is actually this. So if you like see this, then you can see that like the 1, 2, sorry. It's actually this 1, 2. Okay. So like in our mind, we should like input this 1, 2 here. Okay. So now we want to find the MSTD of B of 0, 1. Okay. So let's pronounce it again. Okay. What it is, okay, is the transformation matrix from B basis to standard basis. So it's transforming a coordinate in B to a coordinate in standard. What is coordinate in B meaning in 0, 1? It means that you have 0 copy of this and 1 copy of this, right? And hence, in standard basis, this is in standard basis, and hence the answer is just 3, 5. Okay. And if you remember how to do matrix multiplication, this thing we multiply to 1 will give you the 3. And this thing multiplied to 1 will give you this 5. And hence, you have the 3, 5 on there. Okay? So that's why, in fact, like after we do these things, we will know that the MSTD B is actually 1, 2, 3, 5. Oh wow, this is not difficult. It's not difficult because if you really look carefully, what it's actually doing is as follows. Oh, sorry, it's definitely not blue, it's green. So you will see like all the things are highlighted with the same color is the same. And this matrix is actually given by just copying this. You're just copying this. There's no other thing special. So how long would it take to like for you to write down this? Easy, very easy. Like it's just a few seconds. Okay. But we remember that like why we like are interested in this is remember like we had like the motivation of the coordinate system, right? The coordinate system we want to say like if we have like a 5, 9, you want to say it's like a 2, 1. So how? So what is this thing? Now, if we have the like a notation of like a transformation matrix, we can think what it actually do, right? Is from like a coordinates in standard basis to the coordinates in B basis. So actually, we shouldn't call it as a coordinate. We should call it a transformation matrix from standard basis to B basis. Okay. So we know the real name of it is not called the coordinates. It's called the transformation matrix from standard basis to B basis. And by the way, it's the same. Okay, it's not. I'm not saying like coordinates. The name of coordinates is useless. It just means that they are the same. Okay. But I didn't solve the question. Question: how to find? I didn't tell you, right? I mean, like I spent a lot of time like trying to like a store, and then I tell you this, and I tell you like you have something like this. But let's try let's try to see this. Okay. Sorry. Probably I would use this. Okay. So first of all, I want to like make you realize something. Like image notification is very very ugly. Okay, but like I really want to make you realize. So for example, if I have like a input like this, okay, it's just a random input. Probably like you and say like a 5 7. It doesn't matter. The problem is like I want to know this thing I multiply to two matrices. Okay, which one would this factor x on first? Is this one x on this first, or this one x on this first? The answer is obvious because this is just next to this, so this will be like worked, like it will be acting on the thing in the first order, and this is the second. Okay? And hence, when you're writing the matrix, when you're pronouncing the matrix, what do? You're pronouncing it as the matrix, transformation matrix, is transforming from the standard basis to B basis, and then from B basis to standard basis. You shouldn't like confuse the like the order, because the order is already like fixed like this. You know that this is the first and this is the second. Okay, so remember very carefully. It's like very important. So order of operation. Pronunciation. I don't know how to spell. Sorry. Okay. So, return to like what we had. Sorry. So now, what does it really is? Okay, what this action is? You are having a matrix turning a standard basis, standard coordinates to B coordinates, and then you have the B coordinates turning back to standard coordinates. So what is the total action? The total action is nothing. We have done nothing. We have done nothing, and the nothing like transformation, right? Sorry, I should say like a done nothing. Okay. Since like if I say nothing, it'll be zero. But done nothing transformation is exactly the identity. Okay. Identity. Okay. But I still didn't tell you what it is. But look at this. This is one of them. This thing we know, right? And they multiply to I. What it means. So you can prove, that this thing is actually the inverse of this. And now you might have complained why I need to use like this notation. You have like three things, and I'm just like merging them together like I don't know like a monster. Why I'm using this thing? Because when you're using this thing, actually it makes much sense. The -1 is just inverting these two. Isn't it easy? Because much easier. Okay. And now, for example, how to find it? Like how to find? STTB. So it's just like an inverse of this, right? And it's just like the 1, 2, 3, 5 inverse. And to remind you, probably you haven't learned it, or like if you learned it, the way to find the inverse is to do this. Okay? So you put the like a matrix on the left, and then you put I on the right, and then you do it until you get a like 1001. So it's like a row operation. Okay. And this thing on the right will be your like inverse. So you should try to do it yourself. But like this is the point. Okay. So now I've taught you how to find this thing, how to find this thing. Okay. Seems useless. So now we're going into like a third chapter, which is called a B matrix. And to talk about B matrix, it's the easiest to like do it when we are like thinking of an example. So example, find the matrix. Of course, in standard basis, right? Which like corresponds to the action of of reflecting factors over the straight line y equals 2x. Okay. So what is this question? Let me draw you the picture, then you will be like much clearer. So now you have a line y equals 2x. Okay, and then you want to infer you want to reflect things. That's all. When you have something like this, then you want to infer something like this. Okay, so this is like an action. You want to find the matrix. Difficult, extremely difficult. Let's try to find something we are sure about. For example, if it's on the line. If it's on the line, let's try to find a factor which is on the line. So y equals 2x. So that means that you will have y is 2 times of x. So probably like this is a good factor. So 1, 2. So let's try to find the matrix. Okay, so the matrix, let's say like the transformation is t. So let the transformation be t. Sorry. Okay, so t of 1, 2 is actually 1, 2. Okay. And let's try to see another factor. If we have a perpendicular factor, what would it mean? So perpendicular factor, how to find it? You invert this two, and then you add the minus sign, to add a appropriate minus sign. Here the x coordinate is a negative, so you're adding like a negative on here. Okay. So t of this thing is actually minus of this, right? Because you need to reflect. Okay. Fine. So if we let the basis to be this, let's try to understand t in terms of the basis of this, using this basis only. Okay. T using this basis. What does it mean? I only want the inputs to be B matrix, to be B coordinates. The output is still B coordinates. Okay. So we totally forget about the standard basis. We only care about B coordinates. Okay. Let's see. This B coordinates. What is the P coordinate of this? This 1 copy of this and 0 copy of this, right? I mean, I chose it to be. So that's why the input is just 1, 0. Because it's 1 copy of this and 0 copy of this. Okay. What is output? Output is same. This 1, 2 is 1 copy, is 0 copy of this. So you have like 1, 0. Easy. T, B, let me pronounce you again, okay? Is the T base, like a T transformation in terms of the B basis. What it means, the input is B, the output is B, okay? So what is it? Let's see. So this vector is actually 0 copy of this and 1 copy of this. And hence, it is this coordinate. And the output is minus this. So it's like minus 1 copy of this and 0 copy of this. That's why it's like 0 minus 1. And if you remember what this is a matrix. And then if you are like, if you look at this like 1, 0, 0, 1, it tells you the first column and the second column. If you don't really like catch up until this point, try to imagine how you would like multiply the matrix, and you will see it. Okay. If you still can't understand, try to re-roll it like a bit earlier, and you will see like the similar structure there. Okay. Okay, fine. But now I want to find the t in terms of standard basis. How come? How could we do? How could we do that? Okay. So the point here is to use the following diagram. Okay. So let me try to notate this diagram carefully. So to left to right. So here like if there is like something on the left, something on the right soon. The left to right is the t action. It's a reflection here, or any t you like. Okay. We have like standard basis to standard basis. Okay. What is this? This is a t standard because from left to right, we always insist that there is like a t transformation. Okay. So it's a t transformation in terms of standard basis because these two are the standard basis. Okay. So if I have b basis, what would be like the linkage? The linkage is actually tb because the input is in b basis, the output is also in b basis. So the horizontal action is t, and that's why this is like a t matrix in terms of like a b basis. Okay, easy. What is the like relationship between them? The relationship between them is that like you are like having a transformation. So for example, like you should probably remember that this is easier to find. So like let's try to like stick with this. It's the b basis to standard basis. Okay, and this is the b basis to standard basis. Okay, and we say this diagram commutes because like we are like insisting like this is like a t and this is like a just like a usual transformation. And now, like, let's try to write down this thing. And like, how to write down this thing is as follows. You are having like a t std. It's written down like here in the composition of this three. Okay. So how to like compose this three is as follows. So you have this thing first, and then this thing, and then this thing. Remember, in the like a previous like a section, like previous remark, we have things written in this order. So the first order, second order, third order. Okay. So let's see. So this is the like the sequence. First of all, we are doing this, but you can see, oh, the arrow is actually like inverted. What does it mean? It just means that you need to like make a inverse. Right? Because this is inverted, right? If you're trying to be like a pretentious, you can say, oh, it's just like the standard basis to b basis. And by the way, like I'm just saying this to be pretentious, but in fact it has some like good properties. But like let's see. But like in calculation, you need to do this because like this is the matrix you can easily find, but not this. Okay. And then you're having this thing, which is tb. Oh, sorry, it's not this color. tb. And finally, this matrix M std b. Okay, so this is the formula, right? Because of this diagram, so you know that this is the formula. Okay. So before I continue, let's try to examine what is in this formula. This thing you know how to do it. It's just copying the b basis. This thing you know how to find it. Minus inverse, you know how to do it because like I told you about like the row operation. You should revise it. And for TB, you know how to do it because the TB is easy. The TB is like you chose the basis such that the thing is very easy to find, and the TB is like just here. It's very easy. And hence the multiplication, you know how to do it, and this TSTD can be found by like just multiplying these three. Okay? No problem. By the way, like why I need to write it like this. So let's try to focus on pronouncing this, okay? Remember we pronounce from right hand side because like this is the first like a matrix, okay? So we are having a standard input. We output a B coordinate, and then the B coordinate is going inside here. The input is B coordinate, and then it like carries through the T process, and then the output is still B coordinates because like T is like input is B, output is B. Now you go for here, the input is B coordinates and the output is standard coordinates. So what it does, it input standard, and then using this B to go for this T, and then the B goes back to standard. So in fact, the input is standard, output is standard, and we have done T. And that's why input is standard, output is standard, we have done T. It's exactly this like a T base matrix. And I really hope that like this will like be good intuition on like how you should like feel like a transformation matrix, and also like why I'm using this notation because it's easy to track. You can see like STD to B, B to itself, and then B to standard. You can just read it off. You are not going to use like I mean like there are like many good textbooks. They're using like something like STS inverse or something like this. But I mean, of course, math is good in the sense that okay, it's like it looks simple, but it's not simple because our mind is not like accepting this S and T. Our mind is actually accepting this thing. This thing looks complicated, but it actually tells you it's a transformation matrix from standard B. Okay, so I strongly recommend you use this notation until you find that you are very comfortable with that, and then you can abandon this notation. And I hope that you will have a nice day. Thank you very much.